O dash. So now we can join O dash with, let us say, the vector of with force F1. So this will be vector R dash, and the vector joining O and O dash will be called vector phi. So it is easy to see that the position vector R I is equal to R I dash plus phi dash. That is, the original position vector is equal to the new position vector plus the position vector of O dash with respect to O. So let us take the moment of all these forces. Let Ri crossed with Fi is equal to Ri dash plus Fi crossed with Ri dash plus phi crossed with Fi, and which simplifies into Ri dash crossed with Fi plus phi vector crossed with Fi. So taking sum on all these forces, you can easily see that moment of all these forces is equal to the new moment plus phi crossed with the sum of all the forces F, that is summation Fi vectors. Now this is equal to the resultant force, and for conditions of the first condition of equilibrium is that the resultant force is equal to 0. So it means the second term on the right hand side vanishes, and this leaves us with the interesting result that the sum of moments of all these forces about the new point O dash is equal to the sum of the moment of all these forces about the old point O, and this is equal to 0. So the consequence is that it is immaterial whether you choose O or O dash or in fact any other point in space. The third stage is the equilibrium of a system of rigid bodies, that is a system consisting of several bodies which are in contact with each other, or they are interconnected through linkages with each other. This leads us to a very interesting concept of free bodies. How do we get the free bodies? Let us consider a system of rigid bodies. Now we will isolate each individual rigid body from the other bodies, or its subsystem of rigid bodies from the surrounding bodies, and wherever the bodies were in contact with each other, at that point or on those surfaces we will introduce some forces and moments depending upon the type of contact or interconnection, and secondly on this other side of the contact also we will have equal and opposite forces and moments. So the individual bodies or subsystems of bodies are replaced by suitable reactions on both sides. That's how we will get the free bodies. First we isolate them, and then we replace the contacts by suitable actions and reactions. Now taking each free body as a separate entity, we will now consider the equilibrium, and the conditions of equilibrium are again resultant of all the forces is 0, secondly the resultant of all the moments is equal to 0. Let us consider an example to illustrate this point. Suppose the system of rigid bodies consists of a rod which is held by a pin to a wall here, and rod is also connected to the wall with the help of a cord shown here, and then between the wall and the rod there is a heavy disc, spherical or oval disc, which is simultaneously in contact with the wall as well as with the rod. Now, we will break this system into 4 individual bodies. One is the wall as shown here, cord separate, rod separate and disc separate. Now, let us mark down the points of contact. At this point, let us call the contact point as E and D over here. So, there is a point E over here and a corresponding point E over here, point D over here and a corresponding point D over here. Okay. And similarly, for the cord, point C and C, C on wall, C on cord, B on rod, B on cord. Now, one more thing. Now, at all these contact points, whichever we have shown, there will be forces and moments. We will see that for different types of contacts, here there is a contact between a flexible cord and a wall. The reactions we will see will be different. For example, cord will be under tension here, which will be an axial force over here. So, there will be equal and opposite force on the wall as well as on the rod. Similarly, here is a pin joint at A. At this point, there can be a force, horizontal force and a vertical force. But on the rod, there will be equal and opposite force. This force is towards right and this force is towards left. This force on the wall is upward, on the rod it will be downward. Okay. Similarly, between wall and the disc depends upon whether the contact is smooth or rough. Let us assume that the contact is very smooth, there is no friction. So, on the wall there will be a compressive force, similarly on the disc there will be also a compressive force and normal to it. Similarly, over here on the between at point D there is a force here. Suppose it is also smooth, then there will be a force, equal and opposite force. So, this is how you will isolate the bodies and replace the contacts with suitable forces and moments. Now, let us summarize about the free bodies. Reactions on two contacting bodies are equal and opposite on account of Newton's third law. We all know about it. Secondly, the type of reactions produced depends upon the nature of contact. As I said, sometimes the contacts are smooth contacts, frictionless contacts, on other time they are rough contacts, that is there is friction. So, each type of contact will have its own reactions. So, as well as on the surfaces. Finally, sometimes it is necessary to consider internal free bodies such that the contacting surfaces lie within the given body. We will take up this issue later on, because this is not immediately relevant for rigid body mechanics.